Hello students, today's topic is factor theorem. Factor theorem is an extension of remainder theorem. Remainder theorem we have discussed in the previous video and we have discussed number of problems related to remainder theorem. Today we are going to discuss about factor theorem. Let us understand the concept of factor theorem. I am taking an example of numbers. 35 is divisible by 5. 35 I am dividing with a 5. You observe when we divide 35 with the 5, you get the remainder and the remainder comes to be 0. Remainder is 0 and the quotient will be equals to 7. Quotient is 7. From here, the two cases arises. The first case, when we divide 35 with the 5, we get the remainder 0. It means this 5, which is a divisor here, this 5 is a factor. This 5 is a factor of 35. Why it is a factor? Because the remainder is 0. And second case arises here about this 35. 35 is a dividend. When we dividing 35 with the 5, remainder is 0. It means this 35 is a multiple of 5. So it means whether 5 is a factor or 35 is a multiple of a 5, one thing remains same, that is the remainder. Remainder should be equals to 0. So from here, what we conclude? We conclude that for checking factor or multiple, remainder should be 0. So let us apply this concept for a polynomial. Let us take an example of a polynomial. If f of x is a polynomial, it is divisible by g of x. And in any case, we get the remainder 0. If the remainder is 0, again, two cases arises here. The first case, this g of x, which is a divisor, it is a factor of f of x. And secondly, this f of x, which is a dividend, it is a multiple of g of x. So what I want to conclude here, whether you want to check factor or multiple, remainder should be 0. Now let us try the exact definition, a statement of a factor theorem. This is the formal statement of a factor theorem. If p of x be a polynomial, if p of x is polynomial given to us whose degree is greater than 1 and a is any real number, then first case, if x minus a is a factor of p of x, as I stated earlier, x minus a is a factor of p of x if remainder is 0, and we already know from the remainder theorem that p of a represent remainder because we are dividing this with the x minus a, so p of a is a remainder and that is equals to 0. So this condition is about factor. X minus a is a factor if remainder is 0. This factor theorem is applicable both way around. In the second case, if p of a, which is a remainder, if remainder is 0, then we see that x minus a is a factor of p of x. So this factor theorem work conversely as well. So ultimately what we want to conclude from the factor theorem, this will work on the same way as remainder theorem. If we want to check that x minus a is a factor, we have to check remainder. If the remainder is 0, we would say that this x minus a is a factor of p of x. This will be clear to you with the certain examples, certain problems. Let us try some problems related to factor theorem. Now this is the first problem we're just going to try here. Determine which of the following polynomial has x plus 1 a factor. This is the first problem we will discuss here. In the first problem, this is the polynomial given to us and we want to check that x plus 1 is a factor of this polynomial or not. The first step for this one, we consider the polynomial as p of x and we are finding remainder. Finding remainder, the process is same as we are following it for the remainder theorem. We are substituting x plus 1 0, finding x which is minus 1 and finding the value of p of a minus 1. When we substitute the value of x as minus 1 raised to power 4 plus 3 minus 1 raised to power 3 and substituting the rest of the values. By solving this expression, minus 1 raised to power 4 always gives you 1 and minus 3 plus 3 minus 2 plus 1 and completing solving this we get 0. So what we conclude here, we conclude that x plus 1 is factor of p of x. Why it is a factor? Because this p of a minus 1, that is a remainder and the remainder is 0. So this is the process which we follow for checking factors. The only thing you have to check remainder and the remainder should be 0. Let us discuss few more word problems. Now this is another problem. We want to check that x plus 1 is a factor or not. The process is same, considering polynomial p of x, substituting x plus 1 0, finding x from here minus 1. We get p of a minus 1. It is equals to minus 1 cube, substituting the value of x as minus 1 in this polynomial. When we solve it further, we get minus 1 cube minus 1. Minus 1 square is 1, this minus as such. Now here this is the important step. This is the minus sign we have here. This is the minus sign I have here. And this is the minus sign here. The two negative sign, it become positive. This is the minus sign here and this is the minus sign here, it become positive. Plus root 2 as such. Solving this further, we get 2 plus root 2. This minus 1 minus 2 cancel with the 2. We get 2 plus root 2. You see that x plus 1 is not a factor of p of x because in this case the remainder is not 0. Let us try another problem. In this question, we want to check whether p of x is a multiple of g of x or not. Here, where p of x is given to you and g of x is given. As we have already discussed in the video, what is the condition for multiple? P of x should be a multiple of g of x. The condition is same. We have to find the remainder. Remainder should be 0. So let us continue with this problem. Considering the polynomial p of x, this is already given. Substituting 2 minus 3x 0, finding x from here. X comes to be 2 by 3. Next step, we'll substitute the value. We substitute the value of x minus 2 by 3 in the polynomial. We get 2 by 3 cube minus 2 by 3 plus 1. Solving this further, we get 2 cube is 8 by 27 minus 2 by 3 plus 1, that is 17 upon 27. You see that since remainder is not 0, so we say that p of x, it is not a multiple of g of x. So again I am repeating, condition for factor and multiple is same, remainder should be 0. As in this case, remainder is not 0, it means this p of x is not a multiple of g of x. Let's have one more problem. In this problem, you have to find the value of a k if x minus 1 is a factor of p of x. In each of the following cases, we will discuss few questions, few practice questions from the same question. X minus 1 is a factor of p of x. In this question, how this question is different from the previous question? In this question, x plus 1 is already given as a factor. We have to find the value of a constant, which is k. Let us try the first part. In the first part, p of x is 2x squared plus kx plus root 2. And here x minus 1 already given as a factor, so we substitute x minus 1 0, finding x from here which is 1, and according to the question, the condition is p of a 1 is equals to 0. This is a certainly important condition. Why this condition I am writing here? This is already given the question that x minus 1 is a factor. If x minus 1 is a factor, remainder should be 0, and you know that this p of a 1, it represents the remainder, and this remainder is 0. So this condition is given in the question, so we are applying this condition here. Let us substitute the value. We get 2 times over 1 square plus k into 1 plus root 2 0, and by solving this completely we get the value for k minus 2 plus root 2. So this is the unknown value for k we just found here. This is another question. In this question, find the value for k if x minus 1 is a factor of p of x in each of the following cases. This is the second part of the previous question. Here it is given k x square minus 3x plus k. Considering the polynomial p of x, substituting x minus 1 0, finding xk. Condition, according to the question, the condition in this question is here, that is p of 1 is equals to 0. Substitute the value for k x as 1. Solving this further, we get k minus 3 plus k is 0. 2k minus 3 is 0. And value for k is 3 upon 2. So this way we have solved the problems related to factor and multiples. Let us try one more problem. In this question, we have to find the value of a. A is again a constant. If x minus a is a factor of this polynomial. The question is same as previous question, but this question is given in term of a. Let us start with this problem. Here we consider the polynomial p of x. This polynomial will be considered as p of x. Next step, substituting x minus 1 0, x minus a in fact, and p of a is equals to 0, because when we substitute x minus a 0, x comes to be a. P of a is 0. Substituting the value, you get a cube minus a into a square plus 2a plus a minus 1 0. This a cube, a into a square, that become a cube plus 2a plus a minus 1 0. Here this a cube and minus a cube, this a cube and minus a cube, it cancelled. We left 2a plus a, which is 3a, is equals to 1. 3a is equals to 1, and the value of a is equals to 1 by 3. Here some practice question related to this topic. Thanks for watching this video.